All right, let's talk about something pretty crucial in the world of data engineering. We've got all these incredible tools for streaming and processing data, but how do you get them to work together? On time, in the right order, and without falling apart. Well, today we're going to dive into Apache Airflow, the tool that does exactly that. It orchestrates the whole show.
So let's think about it like this. Imagine all your data tools, Spark, Kafka, all your databases. They're like brilliant musicians in a massive orchestra. Each one is a virtuoso, amazing at its own job. But if they all just start playing whenever they want, what do you get? You get noise, you get chaos. What you need is a conductor. So who directs this modern data orchestra? Before we get to the solution, let's really understand the problem. Picture this. You've got dozens, maybe hundreds of data jobs that all depend on each other. Job B can't start until job A is finished. Job C needs both of them done. So what happens if one of them fails in the middle of the night? Without a system to manage all this, you're looking at pure chaos. Deadlines get missed, data gets corrupted, and honestly, you have no idea what's even running. For a long time, the go-to for this kind of thing was a simple scheduler called a cron job. And look, cron is great if all you need is to run one single script at, say, 2 a.m. every day. But the second you need something more complex, like run this job only after that other job succeeds, or if this job fails, please try it again 3 more times. Well, cron just falls flat. It wasn't built for the complexity of today's data pipelines.
And this right here really says it all, doesn't it? Handling dependencies between jobs. Cron can't do it. Automatically retrying a failed task? Nope. A nice visual interface so you can actually see what's going on? Not a chance. You can see how quickly this becomes a huge problem. It really is like comparing a basic metronome to a full conductor's podium with the entire score laid out. One just keeps time, the other directs the entire symphony.
So, it's time to meet our conductor. This is exactly where Apache Airflow steps onto the stage. It's the platform that was designed from the ground up to bring order, to bring precise timing, and to bring harmony to that chaotic data orchestra we were just talking about.
Okay, so here's the official definition. The key phrase here is workflow orchestration platform, and that's super important. Airflow isn't just a simple scheduler. It's a complete system for designing your entire data process as code, then letting it run and watching over it to make sure everything goes smoothly.
And this is where it gets really powerful. First off, you write your pipelines in Python. That's a huge deal. It means your infrastructure is now workflows as code. You can use version control, write tests, and collaborate just like any other software project. Plus, you get a fantastic visual UI to see exactly what's happening. It handles failures like a pro with automatic retries and alerts. And maybe most importantly, it integrates with pretty much everything in the modern data world. AWS, Spark, Kafka, you name it.
Now, if there's one thing to really get about Airflow, it's this. Airflow itself isn't the truck that hauls your data from A to B. Think of it more like the central traffic control system. It's the brain of the operation, telling all the trucks when to leave, which routes to take, and what to do if there's a traffic jam. It's not the muscle, it's the intelligence making sure the whole system works.
So, how does this conductor actually work? How does it read the sheet music and tell all the musicians what to do? Let's take a quick look under the hood at the core ideas that make Airflow tick.
First step, you'll always hear the term DAG. It stands for Directed Acyclic Graph, which sounds way more complicated than it is. Really, a DAG is just the master plan. It's the entire musical score for one performance. It defines every single step and, crucially, the relationship between all those steps.
And inside that DAG, you have tasks. A task is just one specific step in that plan. It's a single unit of work. So going back to our orchestra, a task is like the instruction, okay, violin section, play these next 8 bars, or percussion, you come in now. It's one specific concrete action.
And how do you define what a task does? Well, you use an operator. Think of operators as pre-built templates for all the common things you'd want to do. Need to run a SQL query? There's a SQL operator for that. Need to kick off a Spark job? Yep, there's a Spark operator. They are the ready-made building blocks that lets you put together really complex pipelines super quickly.
And here is where the magic really happens, right in the Python code. You can see we define task 1 and task 2. But that last line, task 1 -- task 2, that's it. That's how you tell Airflow the most important thing. Task 2 cannot and will not start until task 1 has finished successfully. It's that simple line of code that creates the dependency, the order, and that's what makes Airflow so incredibly powerful. Okay, enough with the theory. Let's see what this looks like when the symphony is actually in performance. How does Airflow conduct a real, honest-to-goodness data pipeline from start to finish?
So here's a totally classic data pipeline. First, at the scheduled time, Airflow gives the cue for step 1, extract. It kicks off a task to pull data from an external API. It then waits. Once that's done, and only once it's done, it signals step 2, load that raw data into cloud storage like S3. Next up, the heavy lifting. Airflow triggers a big Spark job to process and transform all that data. Once that's complete, it cues step 4, store the clean, processed data in a data warehouse like Snowflake. And for the grand finale, once the data is ready and in place, Airflow gives the final cue, refresh the business intelligence dashboard so everyone in the company sees the latest numbers. It manages that whole sequence perfectly.
And you better believe this isn't some niche tool. It is the absolute backbone of data operations in almost every industry you can think of. E-commerce sites use it to update their inventory levels every day. Banks use it to run their critical risk models. Media companies literally use it to power the recommendation engines that decide what movie you're going to watch next. It's everywhere, quietly running in the background. So, let's bring it all home. Why does Airflow get a standing ovation from data engineers? Why has it become such a non-negotiable, essential part of the modern data stack?
Well, it really comes down to this. Airflow delivers on all the things that a modern data team absolutely needs. It gives you true automation, so no one has to manually run jobs anymore. It provides scalability, easily managing hundreds of complex pipelines. You get transparency from its UI, so you're never in the dark. You get reliability because of its built-in retries and failure handling. And because it's just code, it plugs right into professional software practices like CI/CD. It basically turns potential chaos into a reliable, observable, and professional system.
If you take away just one single thing from our little explainer today, let it be this. Tools like Spark and Kafka, they're the amazing musicians doing all the heavy data processing. They're incredible. But Airflow? Airflow is the conductor. It's the one thing that brings them all together to create a seamless, automated, and reliable data symphony.